In this part, now we have a graph of a transform function. So let's take a look at this graph. It's a U shape, so that means it's a quadratic graph. So if the parent function first I'm going to write out the parent function for this type quadratic. So the parent function is y equal x squared, or also f of x equals x squared. So we need to determine the transformations from the origin. So we see that it moved 1, 2, 3 units up, and I'm comparing it with the vertex right here. Here's the vertex. So it went up 3 units and then right, or it moved to the right 1 and then up 3. So I'm going to write the transformation. Doesn't matter what order. So 3 units up and 1 to the right. So since it's 3 up and 1 to the right, now we're going to write our equation. So for quadratic, since we have 1 that's moving to the right, that means that I'm going to use f of x. F of x, well actually I can't, because f of x is already to this parent function. So say I use g of x. So since we have 1 unit, we have a number where it moves to the right, so that means that we're going to have x minus 1. And I'm going to put parenthesis on it, square, because it's quadratic. Now we have 3 units up, so that means it's going to be on the outside after the function, plus 3. So our transform equation is the square of x minus 1 plus 3. So that will be our final answer for this graph right here. G of x equal x minus 1, g of x equals the square of x minus 1 plus 3. With this second graph of a transform function, we see that it's the square root. So for the square root, I'm going to write the parent function. So say it's, again, f of x equal the square root of x. So now this one doesn't have a vertex, so we're going to look at the starting point, the first point, which is right here. So compare it with the origin, we see that it moved 3 units to the right and 2 units down. Again, order does not matter, so you could say 2 units down and then 3 units right. So I'm going to say 3 right and 2 down. So 3 to the right, 2 down. So we're going to write the equation for the transform function. So say it's like h of x. Now since we have 3 to the right, that means that it's going to be within the function, so within the square root. So I'm going to write x minus 3. Minus 3 means 3, right? And then the square root. So since this is 2 down, I'm going to write minus 2 after the function, not within, after. So here, the square root of x minus 3, so 3 to the right, and then minus 2, so 2 down. So our equation for the transform graph is h of x equal the square root of x minus 3 minus 2. Now, for our third example with a transform graph, we see it's a V shape. So that means it's an absolute value. So the parent function, or the equation for absolute value, will be f of x equal the absolute value of x. Now again, the reason why I write out the function for the parent function, or I write out the equation for the parent function, is so that when I get my final answer, I can compare it if it looks similar. So in this case, absolute value, it should have the absolute value lines. So let's look at this one. This one has a vertex. So if we compare it with the origin, we see that it moved 1 unit to the left and then 3 units down. You could say 3 units down and then 1 unit to the left. So let's write out the transformation. So it's going to be 1 to the left and then 3 down. So 1 to the left and then 3 down. So that's the vertex. Now we're going to write the equation for the transform absolute value. So say it's like p of x equal, now since we have one unit that's going to go to the left, so that means this right here is within the function, so within the absolute value. So that means x plus 1, so plus 1, that means 1 unit to the left, and then absolute value, since we have 3 down, that means minus 3. So our equation for the transform absolute value is p of x equal the absolute value of x plus 1 minus 3. So again, now I can compare. It's like, yes, this one has absolute value, so it should be good. So again, here's the equation for the transform absolute value function. So in summary, we went over what the transformation looked like on the graphs and determined how to write out the transformation when given equations. Now how to write equations when given transform graphs.